Hi, I'm Peter. I'm a senior studying computer engineering at BU, and just like Alvin last summer, I had a wonderful time working at Red Hat developing various AI applications to demonstrate different generative AI workflows as part of the ecosystem engineering team. And today I'll be walking through what I've learned and how to build smart applications using RAG and Llamastack, going over different components you use and how to deploy them. And so large language models are trained with a finite amount of data, and so if you think about ChatGPT or Gemini, they don't really have access to your personal data or new data that you've never seen before, and they tend to hallucinate or provide false responses when they're presented with this new unseen information. So how do we build smart applications that use our own data that LMs have never seen before? And so retrieval augmented generation is a technique that fills this gap by dynamically providing proper context to a model, enabling to answer domain-specific questions. So to walk through this diagram of how it works, for example, if you're building or you want a model to answer questions about like an outdated piece of furniture or I guess appliance that you have, let's say a dishwasher, you have your dishwasher manual, you're going to prepare that data and chunk it into several small little tiny bits of text. And from each small tiny bit of text, you're going to embed it into a vector representation. So this is a series of numbers that retains the semantic representation or meaning of the words that you're trying to embed. You're going to store that in a vector database, and then when you ask a question, for example, what does this error code mean if I see it on my dishwasher, you're going to convert that into a corresponding vector representation and try to find the most semantically similar vectors inside the manual that you just embedded into your database. And from there, you can construct an augmented prompt to your model. And so you can present it with the proper context and also the question so that your model can answer any question on your own data, such as if your dishwasher broke down. And so by supplying models with proper context, RAG reduces hallucinations and grounds your response to factual content. And so let's go over the different components that you need to build a simple RAG application for yourself. And so first of all, you would need a model, right? You need an inference model to generate and collect responses. And so you can use something like a VLM inference server, which is a high throughput, very fast, efficient inference engine. You can use a cloud provider such as ChatGPT or Gemini. You would need a vector database to hold your vector embeddings, such as PostgreSQL. It has an extension called pgvector that allows you to store vector embeddings into your database, as well as a lot of other open source options and different cloud options you can choose. And you would need a front end for users to interact with your application, such as you can choose a simple one, such as Streamlit, which is a Python library for front end visualizations, or you can choose to use React or some other stack for visualizing your application. And so how do you connect all these different components to create a very comprehensive application for your users? That's where Llamastack comes in. We'll go over Llamastack in the next slide, but think of it as a connecting layer that allows you to interact with all your AI components in a standardized way. And so going over to Llamastack, it's a unified API layer. One of the major problems in AI application development is that there are so many different AI providers and services, each with their own endpoints and APIs. Think about when you're calling OpenAI, ChatGPT, an endpoint, or you want to use Gemini, or you want to use a Llama. They each have their own different methods for calling, and it's really hard to switch up your application if you want to choose a different provider over another. So Llamastack solves this problem. It's an open source project released by Meta, and it standardizes these core building blocks in AI application development. So you can choose whatever provider you want, and no matter what vendor you use, you can configure this backend server that exposes APIs for inference, agents, vector input operations, safety models, telemetry, and also tool calls. And so it's always the same set of APIs no matter what provider you use, whether it be Ollama, VLM, OpenAI, and Postgres. Here's an initial list of some providers that Llamastack supports. It's not the full list. You can see that on their website. And so in general, Llamastack helps you easily get started in quickly building your applications. It has many different SDKs and support in Python, Swift, TypeScript, and Kotlin. And so we'll go through an example application that I built over the summer to demonstrate this tech stack and how Llamastack helps simplify and speed up development. So over the summer, I developed this GitHub RAG assistant for users to kind of get more information about what repositories they're working with. And so users can enter a repository that they want to learn more about. And after saving their repository and storing all the documents there, they can ask further questions, for example, how to deploy this project or what the architecture of the project is. And the model, using RAG and Llamastack, will be able to answer your question and provide a sources tab where with the documents that you use to answer your question. And so to go over the workflow of how this application runs, a user first enters a GitHub repository, and then the repository is cloned and filtered, and then each document is chunked, embedded into this vector representation that we were talking about before, and embedded into the vector database. And so Llamastack does all this for us, connecting, registering, and talking with our database, no matter what database provider you're using the Llamastack RAG tool. And so Llamastack also offers a rich agent framework that you can use to connect with tools. And so when a user like you is asking a question about their GitHub repository, what Llamastack can do is that you can use an agent, and an agent will see if it knows enough information to answer your query. And if it doesn't, it's going to look through its tool calls, its tools that you've given it by setting up in Llamastack. And so this tool allows you to use RAG. So it's going to follow the same workflow that we described before. It's going to input the search query, convert it into a vector representation, and then search through the vector database for the most semantically similar documents. So for example, like a README or maybe a deployment file. And then it's going to provide all these chunks to the agent to provide enough information to answer your question. And this loop continues until the agent has enough information to answer a user question. And this is all done using the Llamastack RAG tool. It's a little abstracted from what I guess the RAG workflow really is, and it lets developers able to quickly build out this cycle and build their applications. And so now with the completed applications, how do we deploy it and build it at scale and deploy them at scale? And so what you can do is you can use Helm charts. Helm is the package manager for Kubernetes. Kubernetes is a container orchestration platform that automates the deployment and management of containers applications on a cluster, making it easier to run and scale them reliably. It offers features such as automated scaling, load balancing, and fault tolerance. So using Helm, each service, like if we're thinking about a Llamastack server, or I guess your front end, each service can be packaged into a Helm chart, which are essentially blueprints for deploying it onto a Kubernetes cluster. And so the team I was working at Red Hat was focused on developing many different Helm charts for different AI application components. So the components that I was talking about earlier before about Llamastack, about a Postgres vector database, about a VLM server, all these components are already developed for you in this open source repository called AI architecture charts, which I will link further in the next slide. And so it's a curated set of AI components that work seamlessly together. And so if you label them as dependencies in your own Helm charts, you can quickly pull them from the repository and deploy them onto your Kubernetes cluster. And so that's pretty much it. I hope that this workshop has kind of given you a better understanding of what RAG is and how you can use it to develop your own RAG applications and deploy them on a cluster of your choice. I've attached links to the AI architecture Helm charts repository that my team has been working on, as well as the GitHub RAG Assistant example that I went over. And feel free to connect with me and reach out with the links below. Thank you so much.
Thank you so much, Peter. If anybody has any questions, I can just pass the mic. Just raise your hand.
Yeah. Vance?
So, so maybe this is more of a background question, but I hear the word vector database get thrown around a lot. Could you go into a bit more detail, like why exactly we need vector databases instead of just using a regular database?
Yeah, so vectors are a numerical representation of data, and so using vector databases, we can easily find similar semantic representations of data because you can use cosine similarity with these. You can use mathematical operations on these vector representations as compared to like text. It's really hard to run these sort of semantic operations context, and numerical data is the best way of representing this and being able to retrieve them at such high speed and scale. David?
So what are some of the problems that you ran into with the RAG model? Was there any kind of complications that you had around connecting specific agents to the RAG generations that you did for yourself?
I first started off with like a naive representation, like a naive implementation for a GitHub RAG assistant, just like provide no agents at all and providing it with just like the context and stuff and I guess pieces of context from the GitHub repository that I want to provide to the model. But I think the Llamastack agent library is pretty comprehensive. It has a really robust agent execution loop. I don't know if you have more experience with Llamastack, but I think the agent framework is pretty solid. It works really well out of the box, I would say.
Do we have any more questions from the audience?
Thank you.
Thank you.